All right, so in question 5, we're trying to see is one day of the week more, I guess, popular for babies to be born on, okay? Here was not the expected, here's the observed data from a random sample of 84 births in a year from a local hospital. So we're trying to say, based on this data, is it reasonable to conclude the proportions of births is not the same for all days of the week? Okay, so again, just like question 1, our null is going to be that the proportion is the same for every day. Okay, so I said babies are born evenly across the days of the week. Okay, as long as you've got something saying that the proportions are equal, you'll be okay there. And then my alternative, I said one of the days of the week is more likely than the others for babies to be born on. Okay, so again, something about the fact that one or more day is more likely than others. Okay, so then we have to find our expected counts. Okay, remember that takes the proportion. The proportion of the expected count times the total number. So I did 1 out of 7 for each day of the week, times 84. Okay, gives us 12 for each day of the week. Okay, so those are our expected counts if it's the same across the board for every day. Okay, let's check our conditions. Okay, we've got random. It was a random sample of births, so we're good there. So random sample. Okay. Is it independent? We've got 84 is less than or equal to 10% of all births at this hospital. I think that's definitely, well, if this is 1 week, then that's definitely less than 1% of all babies born at the hospital. Okay. I would say that's a safe assumption. There's probably more than that. All right. Anyway, large counts. All of our expected counts, have to be greater than 5. Okay, and we have 12 across the board, so we are good to go. All expected, counts are greater than 5. Okay. All right. So then here's the formula for the chi-squared statistic. Okay, we take the summation of observed minus expected squared divided by the expected. So I'll do the first couple, and then I'm going to cut the video off here and then come back with all of it done. Okay, so we're going to do Sunday first. So Sunday, our observed was 6. Okay, our expected is 12. We square that and then divide by our expected. Okay, and then for Monday, our observed was 7. Our expected was 12. We square that and then divide by 12. Okay, and then this goes on and on and on until we hit Saturday, which had 12 births. So we have 12 minus 12 squared. Again, observed was 12, expected was 12. We square that and divide by expected. Okay, so remember, you have to write this out by hand, and you can skip. You write the first 2 terms and then the last term, and then you're okay. All right, so I'm going to go ahead and stop the video here. The next video is going to be the conclusion.